We're now going to learn how to find the derivative of all 6 trigonometric functions and walk through some examples. I have listed the derivatives of all the trigonometric functions here in this table. Let's go over them, and I want to show you some patterns. The derivative of sine x is cosine x, and then the derivative of cosine x is minus sine x. Let's now look at the derivative of tangent x. It is equal to sec²x, and then the derivative of cotangent x is equal to minus cosec²x. Those two derivatives are really similar in structure, and you just have to remember that the derivative of tangent is positive and the derivative of cotangent is negative. Let's go over our last one. It is the derivative of secant x, and it is secant x tangent x. In a similar way, the derivative of cosecant x is minus cosecant x cotangent x. Notice that the derivative of all the trig functions that start with the letter c have a negative sign. When you go to memorize these, I would suggest memorizing the 3 on the left, the derivative of sine x, tangent x, and secant x, and then the derivatives on the right, just follow from those in structure, except that they have a negative sign. When you take derivatives of trig functions, you often have to simplify them. And when you're doing the simplification, you often need trigonometric identities. So I've just listed the 3 trig identities that you can use for simplification right here, just to make it easier. Let's now walk through some examples where we are going to differentiate the following functions. In our first example, we have f of x is equal to x² times sine x. Notice that this function has 2 pieces, the x² piece and the sine x piece. So when we take the derivative, we are going to have to use the product rule. Let's go ahead and let's do that. F prime of x is the first term, x² times the derivative with respect to x of our second term, sine x, plus our second term, sine x, times the derivative with respect to x of our first term, which is x². Now we get that our derivative is x², the derivative of sine x is cosine x, and then we have sine x times the derivative of x², which is 2x. Notice that we can pull an x term out from both of these. So we can write this as x times x cosine x plus 2 sine x. And that's our derivative. Let's now look at our second example. In this example, we are also going to need to use the product rule because we have a first function and a second function. Our derivative, f prime of x, is equal to our first function, e to the x, times the derivative of our second function, which is cosine x, plus our second function, cosine x, times the derivative of our first function, e to the x. We now have e to the x. The derivative of cosine x is minus sine x. And then we have cosine x times the derivative of e to the x, which is just e to the x. Notice that we have an e to the x term common to both terms, so we can pull that out in front. And we're left with e to the x times cosine x minus sine x. And that's our derivative. Let's now look at our third example. This example also has 2 functions. The first function is secant x, and the second function is tangent x. Our derivative then is our first function, secant x, times the derivative of our second function, tangent x, plus our second function, tangent x, times the derivative of our first function, which is secant x. This now gives us secant(x) times the derivative of tangent, which is secant²x, plus tangent(x) times the derivative of secant(x), which is secant(x) tangent(x). Now let's see what we have in common. Looks like we have a secant(x) common to both terms, so we are going to bring that out. So this is secant(x), and we're left with secant²x plus tangent²x. And that's our final answer. In our fourth example, we have a function f of x is equal to sine x divided by 1 plus cosine x. This function has a numerator and a denominator, so it is a quotient, and we can use the quotient rule. Our derivative, f prime of x, is going to be the bottom term, which is 1 plus cosine x, times the derivative of our top term, sine x, and then we have to subtract off our top term, sine x, times the derivative of our denominator, which is 1 plus cosine x. And we're going to divide all of that by 1 plus cosine x quantity squared. I think one mnemonic that might help remember this is thinking of the top term as the high term and the bottom term as the low term, and then the derivative is just low d high minus high d low, all divided by the square of what's below. Let's now go ahead and simplify this. This is 1 plus cosine x. The derivative of sine x is cosine x. And then we subtract off sine x times the derivative of 1 plus cosine x, which is just minus sine x. And all of this is divided by 1 plus cosine x quantity squared. Now let's go ahead and let's multiply things out. Our first term gives us cosine x plus cosine squared x. And then our second term, we have a minus sine x times a minus sine x. So that gives us a plus sine squared x. And then we have our same term in the denominator, 1 plus cosine x quantity squared. Let's now look at this expression, cosine squared x plus sine squared x. That is a trigonometric identity, and that is equal to 1. So we have on top cosine x plus 1, and then we have a 1 plus cosine x quantity squared in the denominator. Those terms are the same, so one of them cancels out, and we're left with 1 all divided by 1 plus cosine x. And that's our final answer. Let's now look at another type of example. In this example, we are going to prove that the derivative of secant x is equal to secant x tangent x. These proofs are really common when you're in a calculus course and learning about trig derivatives. I think the hardest part of a proof is figuring out where to start. The first place to start is by thinking about a function that is similar to secant x that we actually know the derivative of. And that function is going to be cosine. So we're going to start by saying that the derivative with respect to x of secant x is the derivative with respect to x of 1 divided by cosine x, because secant x is 1 divided by cosine x. Notice that this function has a numerator and a denominator, so we can find the derivative using the quotient rule. So we have the bottom term, which is cosine x, times the derivative of our top term, which is 1, minus our top term, which is 1, times the derivative of our bottom term, cosine x. And then we're going to divide all of this by cosine x quantity squared. The derivative of 1 is equal to 0, and the derivative of cosine x is minus sine x. So this gives us minus sine x, all divided by cosine x squared. So this is sine x divided by cosine x squared. Let's go back up here to the top. I'm going to put a red check here. We are looking for our answer to be secant x tangent x. So let's divide up sine divided by cosine x squared into two pieces. We can divide this up like this. Sine x divided by cosine x times 1 over cosine x. And that gives us tangent x times secant x. Let's then rewrite this as secant x tangent x. And we have proved that the derivative of secant x is secant x tangent x. Let's look at one last example. In this example, we are going to find an equation of the tangent line to the curve y is equal to sine x plus cosine x at the point 0, 1. Let's begin by writing down the equation of a general tangent line. That is y minus y1 is equal to our slope times x minus x1. Our point x1, y1 is going to be the point 0, 1. And now we just have to find the slope. The slope of the tangent line to the curve is the derivative of our curve, dy dx, evaluated at the point x is equal to 0. Let's now go ahead and find the derivative. The derivative is the derivative with respect to x of sine x plus cosine x, and we're going to evaluate that at x is equal to 0. The derivative of sine x is cosine x, and then the derivative of cosine x is minus sine x, and we're going to substitute in that x is equal to 0. This gives us cosine of 0 minus sine of 0. Cosine of 0 is 1. Sine of 0 is 0, so our answer for our slope is 1. Now we can take this value and plug it back into our equation, and then also plug in the point 0, 1 in for x1 and y1. This gives us y minus y1, which is 1, is equal to our slope, which is 1, times x minus x1, which is 0. So we have y minus 1 is equal to x, and that gives us the equation y is equal to x plus 1. And that is the equation of the tangent line to the curve y is equal to sine x plus cosine x at the point 0, 1.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.